So today we'll learn the Google Map, how the Google Map works. So we'll design Google Map and see how this flow happens. So for that, let's have some functional requirement where we understand what we want from the Google Map. So that's a functional requirement here. And in a Google Map, if you see when we see navigator, yes, and like in a mobile app, or you can see in a computer itself if you search there. So one point to other point, and we want to know, like we'll usually give the location, and then location from one point to other point, and we want to know distance, how long how long is that distance, and also we want to know how long does it take. So it's a time taken also. So these are the main functionalities uh, in Google Map. And so now this is the functional requirement, and based on that, we'll see how different piece of the component connects here. So let's go for another thing is non-functional requirements. So yeah, non-functional requirement is very much common in almost all system design or any system design we do. That's the common thing. So the one of the first thing is availability. So system should be always available. So when we open the map, we should not down. So it should work. So that's availability. That's another one. You can say accuracy. Okay, so that's a functional requirement. This is non-functional requirement. Here you can add a scalable. So there will be a lot of requests. There are a lot of users, and they all the send request, and the system should handle. So in that case, we need to design the system to scale horizontally, automatically, so that it can handle all the loads. So that's why we need system should be scalable. Another one is low network latency. There should be a lot of API used to talk to different microservice, and in that case, we definitely need real time or very low network latency. Some of the facts we can see here. So fact, there are uh, like we can say the 40 million requests per second. So that's the 40 million users, and there are more than 40 million users, but you can say there are 40 million requests per second. Every second we get that much request, and that's a huge. So that's we need to understand. Another fact is to store the data, we need uh, 40 petabyte storage. And this is this figure we can search in internet, and we can find like how much the storage they need, but roughly at least we get some figure here. So that's the big storage, and that's the request. So now let's start with the flow. When uh, when we are in computer, or when we use any app, and in a Google Map, we can, when we open, we need to give source and destination. right? So start with some actor. Yeah, so this actor can be a mobile app, or this can be the computer itself. And from there, uh, we give source and destination. And when you give the source and destination, then it should return back all these, the map over there. So when you give the source and destination internally, that source and destination internally, that should be converted in lat and long, because every position in a earth has lat and long, and based on that lat and long, we know where is that place. So okay, the request comes, and this request, we know there's a 40 million requests per second comes, this kind of. And then from here we need a load balancer, because the request should route through the load balancer and to different microservices. So there can be multiple load balancer, maybe one load balancer for few dedicated service, another load balancer for other dedicated service. So in a general, I can just say this is the load balancer. And from the load balancer, we need a service to find the different things. So the first of all, uh, when the user give the source, then we need to get the lat and long. So for that lat and long, so for that we can have a service called location detector. And location detector service, it will try to give the lat and long, and that's also works on based on the GPS. So the GPS, the device is in your computer, is in your mobile, and based on that, we need to calculate uh, that lat and long. So in that way we can get the source, like the where to start. And also we give the destination. For the destination also we need a lat and long. So once we have the location, the starting point and the end point, the next thing is we need to find out the route. Okay, so let's have another box here, and that's, I can say, route finder. So it will find the route. So uh, we'll come this here, and that's the one of the difficult service here. So we'll talk about this. And before that, let me add another things. Once we have the route finder, once we get the route, like from source to destination, and which one is the shortest path, and then after that we can display that in a navigator. So that's why we need another called like navigator service. So here I can put navigator service, and with the help of this we can see nicely in a GUI, or when we follow the map, and when we drive our car, then we can see all in a uh, nice picture. So that's we get from the navigator service. So uh, so one of the thing is, when we have source and destination, then we need to find out the path, because from the source to destination there can be multiple paths, and from these multiple paths we need to find the shortest path. So there are two milestones here. First thing is we need to have all the paths. So those all the paths, we can get from, some third party software or roads, like we want to collect all the roads data. So maybe there will be third party software. So I can just put one box here, and I just say this is a service for road data service. So every day, you know, mostly, the road data is, it's mostly same, but every day we see some construction happens, and if there's a new data, then that should be added there. So road service add that. And when we say about, road data lat and long, and we need to find out shortest path, we need to store this in a graph data structure. So for that we need a database, and here I can say this is a GraphDB. That's a GraphDB. So our data is here, and from this GraphDB we need to find out the shortest path. So the route finder will get the shortest path. So in a GraphDB, in order to find, the sorted path, the first algorithm that comes to our mind is uh, Dijkstra algorithm. So you can go to uh, my channel, and then you can search Nandeshwar LeetCode, and then you can search for Dijkstra algorithm, and there is a network delay time, and that's use the Dijkstra algorithms. And here I have talked, how to find, the shortest path from one location to another location. So using the Dijkstra algorithm, we can find the shortest path. So let me connect a point here. Yeah, and we can get the shortest path here. Let me connect this also. Okay, so here we can find the shortest path. So the route finder will use the Dijkstra algorithm, and the data is very big. And when we say it's a very big data for, for certain, or for this road data. So in a big data, if you try to run this Dijkstra algorithm again, it may take a lot of time, to search those things. So in this case, there can be, when we deep dive into this, we can find, multiple ways. So one of the thing is, I can put some locations, that like some popular locations in a Redis. And for the popular locations, and for that we can only go there. That's already in a Redis, that's some in-memory database, and we can search from there. So let me show that in another database here, and I can say I can use the Redis for some popular location. Let's have one point. So if you get from here, that's good. We can get the quickly. If you do not get, we can search in a GraphDB. Again, in a GraphDB, a lot of road data. So again, it will be difficult to search. In that case, also, we can have uh, a different algorithm. Maybe when we give the source and destination, then in that case, we can calculate, like based on the source and destination, we can easily calculate the aerial distance, and that there is already algorithm for that. So, and once we get that aerial distance, so maybe you can check like, okay, if it is in within 300 miles or 400 miles in a certain number, and then in that case, maybe it's easy to search in a graph DB. We can limit, okay, this is our source and destination, aerial distance is this much, and search the data from the graph DB. And if it is like again 3000 miles or 4000 miles, so maybe in that case we need to find some other algorithm, but mostly this works. And when we deep dive into this, we can search again and get the idea. So this is all about the basic flow of this Google Map or any map, their map service. So that's all for now. Thank you.